Alright folks, we are officially recording. First recording of 2017, first period. Alright, today we are doing area and perimeter in terms of x. So let's talk for a minute about what in terms of x means. On these problems, when you see in terms of x, it basically means your answer will have x's in it. Are you laughing at my headset, Marcus? Rude. It means your answer will have x's in it. You're not really going to have just a number answer. You'll have like an expression answer. Okay, so your answer will have x's in it. Now think about how you find area and how you find perimeter. How do you find perimeter of any figure? You add up all the sides. So perimeter involves adding. Area. Think about your different area formulas. Give me an area formula. Length times width. What's another area formula? How about a triangle? How do you find area of a triangle? That's perimeter of a triangle. Add the sides. Area of a triangle is base times height divided by 2, or 1/2 base times height, like William said. Area of a square is side times side. So what I'm trying to get you to notice is that area always involves multiplying. There will always be multiplication when you're doing any kind of area formula. Sometimes there's more stuff, but there will always be multiplying when you're doing area. So think about what's happening here. When you're doing perimeter, you're adding the sides. When you're doing area, you're multiplying somehow, some way. So keep this in mind, because this is a big fact that will help you keep these straight, because lots of kids get these confused when we start getting into these exponent laws. When you are doing area, the exponents will change because you're multiplying x's times x's. The exponents on your terms will change. And that's because area always involves multiplying. And I'm talking about area in terms of x here, when you've got x's in your problem. On perimeter, what we're really doing on any perimeter problem is we're adding all the sides. Okay, so perimeter involves adding like terms. And when you're adding like terms, the exponents never change. So keep that in mind, because kids get this confused all the time. The exponents will not change when you're adding like terms. Now, we did some problems like this last week. We just didn't call it area and perimeter. But we did some problems where we added like terms last week on Thursday. And we did questions in class. Remember how we talked about x plus x equals what? 2x. That's adding like terms. Do you notice how the exponent on the x's didn't change at all? Then we talked about x times x equals x squared. When you're multiplying x's, the exponents change. When you're adding x's, the exponents don't change. The coefficient changes. So keep that in mind. It's a very important fact about these problems. Alright, and the first figure I have up here is a square. How do you find area of a square? That's perimeter. Length times width, but in a square, what's special about a square? They're all the same, so we don't call it length and width because that kind of implies there's two different values. They call it a side. Side times side, or in other words, side squared. Okay, so let's talk about how to find the area of this guy. Now look what the side is. The side is an expression of 3x to the 4th. It's got an x in its dimension. That means our answer is going to have x's in it. Oh, I'm sorry, you were copying? Sorry. Calm down. Can't read what? Perimeter involves adding like terms. And anytime you're adding like terms, the only thing that changes is the number in front. The coefficient changes. The exponents never change when you're adding like terms. So on perimeter, your exponents won't change. On area, your exponents should definitely change on all of these problems. Alright, can I change screens now? Do I have your permission, Victoria? Okay. Caitlin? Yes? And Juan Angel just now started writing. Sorry, you'll have to copy somebody's notes. Alright, area of a square. Area of a square is side times side, and sometimes you'll see it written as side squared. So I want to show you how we can do this problem two different ways, using both of the laws you should already know. I usually just do side times side. What is the side? So we're going to do 3x to the fourth times 3x to the fourth. That's going to be the area of this guy. So what is the area of this square in terms of x? 9x to the 8th. 9x to the 8th. The area gave me a different exponent in my area answer than I started with on my dimension. On area, your exponents will always change when you're doing area in terms of x. Let's work it a different way. Let's just say I wanted to do area of this square as side squared. Let's do 3x to the fourth squared. If we look at it like this, we're still going to get the same answer, because what's 3 squared? 9, and x to the fourth squared is x to the 8th. But I do want you to notice on area the exponents changed. Now, I always want you to label your answers. Area was 9x to the 8th, no matter which way we worked it. Either this way or this way, we still got 9x to the 8th. Perimeter. Perimeter is basically adding all the sides up, but there are some shortcuts. What's another thing you could do for a perimeter of a square? The side, whatever the side is, times 4. Well, look at that side. What's 3x to the fourth times 4? Come on now, wake up. 4 times 3x to the fourth, what is it? Marcus? 12x to the fourth. Perimeter is 12x to the fourth. Look at my exponents. Did they change? No. Because really what we did was we did 3x to the fourth added 4 times. The x to the fourth part doesn't change because you're adding up how many there are. 4 3s make a total of 12 of those guys. 12x to the fourths. Did Juan Angel, you lost your pencil? Why do I put that little thingy thing? What thingy thing? Why do you have to do all this? You don't have to. You pick a way. I usually do it this way when I'm doing area. I just wanted to show you both rules. Either way we wrote the formula, you're going to get the same answer for area. Okay, let's try another one, shall we? Let's look at a rectangle. How do you find area of a rectangle? Length times width. How do you find perimeter of a rectangle? Add all the sides. Or double the length and double the width. And then add those together. We did problems like this, we just never put it into the context of area and perimeter. What do y'all want to do first, area or perimeter? Area. Now, on area, remember I told you the exponents that you start with will not be the exponents that you end up with in your answer. On area, your exponents should change because you're multiplying x's times x's. So for area, I'm going to do 2x to the third times 5x squared, or 5x squared times 2x to the third. Doesn't matter what order. What's my final answer going to be? (10x to the fifth). Okay, because this is 2 times 5. That's how we get the 10. There's 3 x's here, 2 x's here. That's only 5 x's, not 6 of them. Right? So look at my answer for area versus what I started with. When you are finding area, your exponent should always change because you're multiplying x's times x's. Now, perimeter. So there's my area. Make sure you label area equals, perimeter equals. Perimeter is a little bit different. Perimeter is you're adding the like terms. And if they're not alike, you cannot add them. So 5x squared really cannot get added to 2, or it can get added by putting a plus sign in between them, but you can't put them into one term. You see what I'm saying? However, this 5x squared could get added to the other 5x squared across from it. How much is that? I heard somebody say it, but I'm hearing lots of incorrect stuff. We're on perimeter, we're adding all the sides up. Okay, and you can only add terms that are exactly alike. Otherwise, you just put a plus sign in between them. 2x to the third and 5x squared cannot get added into one term because they're not like terms. But these are like terms. What's a 5x squared plus another 5x squared? 10x squared. And this 2x to the third can get added to this 2x to the third. That's 4x to the thirds. And the best I can do between those two amounts is put a plus sign. They can't get put into one term because they're not like terms, but I can put a plus sign to show that I'm going to add them if I knew what x was. This is the perimeter. Now, again, look at your dimensions that you started with. I told you on perimeter the exponents shouldn't change. How many of those terms you have will change. The coefficients changed. I had x to the thirds in my question. I have x to the thirds in my answer. I had x squareds in my question. I have x squareds in my answer. That's what happens on perimeter. The exponents never change. The coefficients change. However, on area, everything changes. Your coefficient and your exponent. Right? Are we good with that? All right, number 3. Everybody's favorite figure, a triangle. Now, area of a triangle. This is the one that kids forget all the time. Area of a triangle, there's 2 different ways to write it. I usually write it like this. Area equals base times height divided by 2. You know a triangle and a rectangle are actually very closely related. A rectangle is length times width. A triangle takes up half the much space as a rectangle would. So what do they do to it at the end? They divide by 2. So it's got an extra step. Guess what kids forget to do all the time? Divide by 2. Sometimes it's written like this, 1/2 base times height. Same thing, dividing by 2 and multiplying by a half accomplish the same goal. Now, on area, your exponents should change because you're multiplying x's times x's. So, on area, what dimensions do I not need? The legs. Base and height have to meet at a right angle. The legs, these 2 sides, I'm going to need when I do perimeter, but I don't need them for area. For area, you need the 2 dimensions that meet at a right angle, the base and the height. So what do I need in this problem for area? 6x to the 4th times 3x to the 3rd. And what am I going to do after I do base times height? I'm going to divide by 2 at the end. Don't forget to divide by 2. Alright, so let's do this. What is 6 times 3? 18. What's x to the 4th times x to the 3rd? X to the 7th. Now, I still haven't divided by 2. Dividing by 2 only affects the 18. So my final answer here? 9x to the 7th is my final answer for area. Always label your answers. And again, notice the exponents I started with in my question are different on my final area answer. One angel here. All right, perimeter. Perimeter is different. Perimeter is just adding up all the sides. And if you can't add them, you stick a plus sign in between them. If you can add them, you put them all into one group. But the exponent part, the variable and the exponent part shouldn't change. The coefficient. You weren't done. Let me go back. Sorry. Okay, so look at the perimeter. What do I not need when I'm finding perimeter? The height. Perimeter is the distance outside a figure, never inside. So for perimeter, I'm looking at these three sides here. 5x to the fourth, 5x to the fourth, 6x to the fourth. Are those all like terms? Yeah, they're like terms. They all are x to the fourths. You just threw it at me. Come get it. Here, let me throw it back at you. Ugh. Gross. Okay. Why do you think they're not like terms, pencil thrower? Okay, coefficients don't have to be the same to be like terms. What has to be the same is the variable part. It has to be exactly the same. Those are all x to the fourth. So, let's add them all up. What's 5x to the fourth plus 5 more x to the fourth plus 6 more? 16x to the fourths. On perimeter, your exponents should never change because all you're doing is adding up how many of them you have. Victoria? Okay, I want to change this up just a little bit. What if this side only had been 6x to the fifth? Let's talk about perimeter if just that side had been 6x to the fifth. Yes. Then we could add these two sides together and make 10x to the fourth, but the best I could do to combine it with this is to put a plus sign in between. So that's how our perimeter would change. Again, on perimeter, whatever exponents you have in the problem, you should have those same exponents in your answer. All right. Ooh, a circle. This is everybody's favorite. Now, these answers are going to be in terms of x and in terms of pi, folks. I'm not expecting you to put in 3.14 and actually multiply by 3.14. So all of these answers, I'm just going to let you leave the pi symbol. It'll be called in terms of x and in terms of pi. But this is the figure where kids constantly get them mixed up. Area, and it's really not even called perimeter, it's called circumference. Area of a circle. To me, a circle and a square, believe it or not, are very closely related. The only additional thing an area has is that pi symbol. How do you find area of a square? Side times side. How do you find area of a circle? Radius times radius. And then you also have to stick a pi in there. So area of a circle is radius times times pi. It's kind of like side times side, and it's got that extra pi in there. Now, how do they normally write that? Pi r squared. But it's the same thing. And I usually, on these, I don't put the pi up front. I usually put it after the radius times radius business. But it could be either way. Okay, so it's very much like a square. Instead of side times side, you're going to do radius times radius, and then just don't forget to stick the pi in there somewhere. Now, how about circumference? There's two different formulas for circumference as well. One involves the radius and one involves the diameter. One of them is 2 pi r, which really I prefer to write that as 2r pi. You can multiply in any order. Area and circumference are not the same thing. Area is the space inside a circle. Circumference is the distance around the outside of the circle. So no, completely different. Now, to find circumference, you can double the radius and stick a pi on it. Or, what is the radius doubled? What is that called? Diameter. You could do pi times diameter. So circumference is really easy when you know the diameter. You just stick a pi on the end of it, and you're done. So circles can be tricky for several reasons. First of all, the formulas, kids forget them. Second of all, I could either give you a radius or a diameter. What do you have to find area? You have to have radius to find area. You can have either one to find circumference, because you got two different formulas. But for area, you must know the radius. Yes, very good. Did I give you the radius for this one? Yes, I did. So I'm just going to apply my formula. Now, some kids like to write it like this. They take the radius and they square it, and don't forget to stick the pi on it. I usually write it like this because I find that most kids are better with the first law that we learned. Either one of these are going to give you the same answer, though. I just think of it as 6 times 6, which is 36. Again, 6 squared is also 36. And then x to the 5th and x to the 5th is x to the 10th. Same thing here. 5 times 2 is 10. And then don't forget to stick a pi on it. You did the top one? These are the same thing. It's just I find most kids make less mistakes when it's written this way. The area of this thing is 36x to the 10th pi. Another thing that would be correct here, guys, would be 36 pi x to the 10th, because all of these are 3 different terms that are getting multiplied. And technically, you could even stick the 36 in the middle, but that just looks weird. Let's not do that. We normally put the number out in front, but on a multiple choice test, they could write it either way, and those are both correct. Now, circumference. This is how I do circumference. First of all, I ask myself, do I know the radius or do I know the diameter? What I always try to get to for circumference is the diameter. And then once I know the diameter, I just stick a pi on the end of it and I'm done. So what do I know for this problem? I know the radius, so I just double it. I'm really using this formula, but I kind of do the doubling in my head. What's this radius doubled? 12x to the 5th. Again, see on circumference, which is just a fancy perimeter, the exponents never change on perimeter. The only thing I need to remember to do, stick a pi on it. So circumference here is 12x to the 5th. Alright, try this one. Area and perimeter, give me both. Give me liberty or give me death, says one angel. It was a rhetorical question. You don't get to choose. Yes, so we're waiting for you.
Hi, how are you?
I don't think they're going to be able to hear you. Isaac says hi to all my other classes. Well, I only had 10 views on my YouTube videos. I just looked. Made me sad. I used to put them on SchoolTube, but SchoolTube doesn't work that great, so I'll put them on Schoology, but it'll connect it to a YouTube. You've never heard of SchoolTube? Alright, area. Once you get this rule down, once you get these down, and we've done several of them, you should be able to do them pretty quickly. On area, your exponents should change. Keep that in mind, because I'm going to do 7x to the 6th times 7x to the 6th. Area always involves multiplying your dimensions somehow, some way. So for area, what's 7x to the 6th times 7x to the 6th? 49 x to the 12th. Perimeter is adding up all the sides. So there's 4 sides that are 7x to the 6 units long. That would be 28 x to the 6. Again, notice on perimeter, exponents didn't change. On area, they did. I know, right? $48x to the 12th. Where'd you get that? 7 times 7 is 49. Okay, how about this one? You try this one, please. don't know. I want to make sure you do each figure that we just did by yourself. So after this, we got a triangle, then a circle. It's not. I agree with the 8, but not with the x to the 12. What, Juan Angel? Add the 4 and 4. I don't see a 4 and a 4. Alright, the area here would be 8x to the 7th. It's 4x to the 3rd times 2x to the 4th. 4 times 2 is how we get 8. And again, for the exponents, you're counting them. I've got 3 x's getting multiplied times 4 more x's. That's only 7 x's. Right? On area, your exponents should change. Perimeter, however, your exponents should not change. All you're doing is adding like terms if there are like terms, and there should be some. So what's perimeter here? 8x to the... Oh, whoopsie, I'm looking at the 2's. 8x to the 3rd plus 4x to the 4th. And usually we like to write highest exponents first, so really it'll probably be written as 4x to the 4th plus 8x to the 3rd. It doesn't matter. Okay, and then how about a triangle for you? The perimeter of that last one was one of these, either 8x to the 3rd plus 4x to the 4th, or flip them around, 4x to the 4th plus 8x to the 3rd. Again, you're adding these two sides, that's how I get 8x to the 3rd. Add these two sides, you get 4x to the 4th. And I can't put these together because they're not like terms. So the best I can do is just put a plus sign in between them. Okay, try this triangle. Be careful on area. Guess what kids forget to do? Divide by 2. No. You're already dreaming about using the restroom next semester. Okay, let's talk about the triangle and not the restroom, shall we, Victoria? Yes, all the sides of this triangle are 8x to the 4th. The height is 9x to the 3rd. This is an equilateral triangle. Alright, who can give me area? Oh, okay. Caitlin almost had it, but she almost forgot to divide by 2. Height is 8. Area is 36 x to the 7th. Because you got to do 9x to the 3rd times 8x to the 4th, and then don't forget to divide by 2. So that's 72x to the 7th, but then you got to divide that 72 by 2. And that's how you get this. Okay, now perimeter. All of these sides are the same. So you have 3 like terms. What's the perimeter of this thing? 24 x to the 4th. You add up all the sides. On area, exponents change. On perimeter, exponents don't change because you're adding all the sides. I just did 8x to the 4th times 3, and 8 times 3 is 24x to the 4th. Because all the sides were the same here. You could have also done this, 8x to the 4th plus 8x to the 4th plus 8x to the 4th. It's going to stay x to the 4th, and 3 eighths make 24. Okay. All right. Just for that, you get a circle with a diameter. And now, for area, folks, you have to know radius. This one is super easy to find circumference. Super, super easy to find circumference. Not so much to find area. You must know what the radius is to find area. So do not try to use 18 in any way, shape, or form to find area. What is the radius if the diameter is 18x to the fourth? The radius would be 9x to the fourth. When you divide by 2, the only thing affected is the coefficient. Okay, so what's the area? So do 9x to the fourth times 9x to the fourth, and then don't forget to stick a pi on there. 81 x to the 8th times pi. Okay, another thing you could do is square the radius. 9 times 9, 9 squared is how we get 81. X to the fourth squared, those get multiplied. 4 times 2 is 8, and then don't forget to stick a pi on it. This is radius squared times pi. Or radius times radius. 9x to the fourth times 9x to the fourth times pi. Again, you're still going to get 81, x to the 8th, and then a pi. Well, it depends on what rule you write it as. When do you add or when do you multiply? If I'm going to write it as an exponent problem, power of power problem, that rule they get multiplied. If I'm going to write it out like factor times factor, radius times radius, then they get added, and you still get the same answer either way. So you need to pick which rule makes more sense to you and write it that way. This is the way I usually do it. Now, circumference. I can't tell you how easy circumference is when you know the diameter, because circumference is just pi times diameter. So just take the diameter and stick a pi on it. So this would be 18x to the fourth pi. Alright, now, the good news for you guys is there's really not a set of problems on area and perimeter in terms of x in the book. So we're going to keep revisiting this in warm-ups. We will have a grade on it. It is something that's on the end-of-course exam, but it's just not in the textbook for some reason. Now, do not fear, though. I do have some homework for you. Your homework is going to be on adding and subtracting polynomials. Now, we did this Thursday, and we did some practice problems Thursday in class, and then we focused on reviewing. I want you to try one of these, and then I'll tell you your homework. Subtract x squared minus 4x from 3x squared minus 2x plus 6. Okay, now you will have a couple of problems like this. And I just wanted to make sure we didn't do one like this in our notes Thursday. First of all, subtraction is tricky. What must you think about when you are subtracting? Parentheses. That's because we're doing it right now. Nobody's done this yet. Now, what do you put first? Also matters. Order matters and parentheses matter when you are subtracting. Yes, the 3x squared minus 2x plus 6 comes first. Whatever comes after the word subtract should come after the subtract sign, and it should be in parentheses. Everything that's being subtracted has to be in parentheses. So when I set this up, it's going to look like this. 3x squared minus 2x plus 6 minus x squared minus 4x. It's really not that bad. All it is adding like terms. With one extra little step, you got to distribute the minus sign. So now 3x squared minus 2x plus 6 doesn't change yet. But what happens to everything that was being subtracted? It changes signs. It becomes a minus x squared and then a plus 4x. And then you look for like terms and add them up. Oh yeah, a 3x squared and a negative x squared make 2x squared. A negative 2x and a positive 4x make a plus 2x. And then what? plus 6. And again, the order doesn't really matter, but I like you to put in an order from highest exponent down to lowest. This would be like perimeter if this had some kind of figure that would look like that. But this perimeter is when you're just adding like terms, adding or subtracting like terms. All right, your homework is going to be on page 156. How about 1 to 25, just the odds? Y'all know what odds are, right? Like 1, 3, 5, 7, 9, 11, 13. It's only like 14 problems. All I hear is wah, 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 wah. These don't take that long to do. Oh my gosh. Y'all are such babies. Okay. 1 through 24, first column. How's that? It's pretty much almost the same number of problems, but we didn't give homework Thursday. This is what we did in class on Thursday. Okay, well, just don't worry about that. Just do these. All right.